Welcome to Pragim Technologies. I am Venkat. This is part 12 of SQL Server. In this session, we'll understand the different types of joins that are available in SQL Server, specifically cross join, inner join, and outer joins. Before continuing with this session, I strongly recommend watching parts 3 and 5 of this video series. Now, joins in SQL Server are used to retrieve data from two or more related tables. In general, tables are related to each other using foreign key constraints. So I have this employee table on the right here, which has got ID, name, gender, salary, and department ID columns. And then I have the department table itself here, which has got the department name, the location that department is present at, and the department head. Now if you look at these two tables are related using this foreign key department ID. Now if you're not sure what foreign key is, please watch part 3 of this video series. So these two are related tables. Now let's say I ask you to write a query which will give me an output as shown here on the left hand side. I want the name of the employee, gender, salary, and the department name. And if you look at the output columns that I require, the first three columns, name, gender, and salary, they are present in the employee table, whereas the department name is present in the departments table. So both, these columns, all these columns are not coming from a single table. They're spread across two different tables. So obviously, if I have to retrieve this output, then I will have to join these two tables. Okay, so to join these two tables in SQL Server, we have got different types of joins. For example, we have inner join, outer join, and cross joins. And again, the outer joins in SQL Server, which we'll be talking about in a bit, are divided into three different categories: left outer join, right outer join, or full outer join. Okay, you can say left outer, right outer, full outer, or you can just say left join, right join, or full join. Now let's talk about inner join. Now let's say, I want output like this. I want the name of the person, their gender, salary, and the department name. Okay, so let's see how we do this using inner join. Okay, and look at this. If you have two tables, in the inner join, the matching rows between the two tables are retrieved. For example, if you look at the employee table here, everybody has department ID except James and Russell. If you look at James and Russell's record, the department IDs are null, which means these rows doesn't have a matching department ID from the departments table. So when I join these two tables using inner join, only the matching rows between these two tables are retrieved, which means the matching rows between these two tables are these 8 rows from 1 till 8, which is what I'm getting. And if you look at the output, I don't get James and Russell's records. Why? Because their department ID does not match with the ID column in the departments table. So inner join will only give you matching rows between both the tables involved in a join. Now let's see how to write the inner join query itself. So if you look at the two tables that we have, in employee table we have got 10 rows, and in the departments table we have got 4 rows. And what do we want? We want the name, gender, salary, and department name columns in the output. From which table? From TBL employee table. And the first 3 columns are present in TBL employee table, but the department name column is present in the departments table. So I will have to join with that table. And to join with that table, you use the join keyword. So TBL department. So we are saying I want to join TBL employee table with TBL department table. Okay, now if you want to join these two tables, how do you want to join these two tables? What's the common column between them? The common column is the department ID column. And to specify the join condition, you use the on clause. So on TBL employee, so in the table employee we have the department ID column, so use that to look up TBL department table and the ID column within that table. Okay, so it's pretty simple. Select whatever columns you want from TBL employee. Now I want to join this table with the TBL department, so we use the join keyword on how do you want to join those two tables. Now between these two tables, the common column is the department ID. Department ID in TBL employee table, join that with ID column in TBL department table. So obviously if we execute this query, we should get 8 records. Okay, now if we execute all of them together, okay, and if you look at the output here in the messages, in the TBL employees table we got 8 rows, in departments we got 4 rows, and in the join query we only got 8 rows. Why? Because if you look at James and Russell, their records doesn't have a matching department ID. That's why inner join has not returned those two records. So if you look at the join output, we don't have James and Russell's records in the output. We only have the matching records between these two tables. Okay, and when you write an inner join query, you can say inner join or just join. I would say always write inner join because this will say your intentions explicitly. Okay, alright, so that's about inner join. So inner join returns only the matching rows between both the tables. Non-matching rows are eliminated. Okay, now let's say my requirement is in such a way that I not only want the matching rows, I want the non-matching rows as well from the employees. Well, basically I'm saying I want all the employees, irrespective of whether they are assigned to a department or not. I want all the employees. So how do we do that? So indirectly you are saying, okay, I want the matching rows plus the non-matching rows from the employees table, which means you want everything from the left table matching and non-matching. Okay, that's when you actually go for left join. So if you look at left join, returns all the matching rows plus non-matching rows from the left table. So there are 8 matching rows. So this department ID matches all for these 8 rows. The department IDs match with the department IDs, but these 2 rows doesn't have a matching department ID. Okay, so but in departments table we have total 10 rows, so all matching and non-matching rows will be retrieved when you use a left join. So when we write a left join query, we should get 10 rows. So how do we write the left join query? Everything remains exactly similar, except that instead of inner join you will say left join. That's it. Look at this. Previously we have got 8 records when we executed that query, but let's now execute this and see how many records we get. So we first go to the messages. Look at this. In employees table we have got 10 rows, in departments 4 rows, and in the query left join query that we have written, we've got 10 rows again. So if you look at the output, now we should have got both James and Russell's records as well, but if you look at the department name column, it's basically null. And it makes sense. Why? Because they don't have a department ID. They are not assigned a department yet, so that's why department name will be null. Okay, so left join basically returns all the matching rows between both the tables plus non-matching rows from the left table, and this picture depicts exactly that scenario. And when you use a left join, you can say just left join, or you can say left outer join. Okay, the query results will not be affected, so the outer keyword is optional there. Alright, now let's say I want all the rows from the right table, including if you look at the two tables here, you have a department called other department, and the department's ID is 4. Now this no employee in the employees table belongs to this other department. Okay, so if there is a requirement, if somebody asks you, okay, give me all the employees, okay, which means I want all the matching records between both the tables plus non-matching records from the right table. Okay, so from the departments table I want other department record as well, irrespective of whether there is an employee assigned to that department or not. So we want all the rows from the right table, okay, plus all the rows including the non-matching ones. Okay, so basically right join will return you all the matching rows between both the tables plus non-matching rows from the right table. Okay, so let's see what happens if we convert this left outer join to right outer join. Okay, so between employees and department table there are 8 matching rows, and in the TBL department table there is this other department which no other employee, no employee belongs to this other department. Okay, so obviously this other department row does not have a matching record in employees table. Okay, and we want this record as well. Okay, so how do we do that? Using right outer join. So when we execute this, we should get around 9 records. So 9 records. So look at this, all the matching rows until Sarah we have got, and other department row. Okay, and if you look at the name, gender and salary columns are null. Why? Because no employee is assigned to this department, so obviously you will not have any name, gender or salary. Okay, so obviously whenever you want to return all the matching rows between both the tables that are involved in a join plus non-matching rows from the right table, that's when we go for right outer join. Okay, so you might have guessed by now, if I want all the matching rows between both the tables plus non-matching rows from the left table and non-matching rows from the right table, then what type of join do I use? Full join. So full outer join gives me exactly that result. These are the matching rows from both the tables. These two are non-matching rows from the left table, and the last row here, other department, is the non-matching row in the right table. Full outer join will give you all the records from both the left and right tables, including the non-matching rows. Okay, so obviously when we execute this query, we should get around 11 records. 8 matching records plus 2 non-matching from left and 1 non-matching from the right table. So how do we write a full outer join query? Just specify full outer join. So when we execute this query, you should see until here all these are matching records, these two are non-matching records in the employee table, and this is a non-matching record in the departments table. So together we have 11 records. Again, you can specify full outer join or just say full join. Okay, so far we have seen inner join, left join, right join, and outer join. Full outer join. Okay, but apart from all these types of joins, we also have another join called cross join. So what does a cross join do, and how do I write that query? First, let's write the query, and we'll look at the output, and then we'll decide what cross join is going to do. So if it's a cross join, instead of saying full outer join, all I say is cross join. Now remember, a cross join will not have an on clause. Okay, I'll tell you in a bit why a cross join shouldn't have an on clause. So when I delete that cross join, and then when I execute this query, look at this. Look at the number of rows that we are getting, 40 rows. And if you remember, how many rows are there in these tables? 10 rows in the employees table and 4 rows in the departments table. And when we execute the cross join query, we are getting 40 rows. So basically what's happening, the number of rows in the employees table is being multiplied by the number of rows in the departments table. So a cross join will give us the Cartesian product of the tables that are involved in the cross join. Okay, so that's what cross join is all about. Cross join produces the Cartesian product of the two tables involved in the join. For example, in the employees table, if we have 10 records, and in the departments table, if we have 4 records, a cross join would produce 40 rows between these two tables. And as I told you, cross join shouldn't have an on clause. Okay, so what basically a cross join does is it will take each record from the right table and then associate that with every record in the left table. So in the departments table we have got 4 rows, IT, payroll, HR and other department. So it will take IT row from the departments table, associate that to every one of the employee in the employees table. And similarly it will take the next record, which is payroll, and associate that. So it basically gives us, the number of rows in the employees table multiplied by the number of rows in the departments table. So it gives us a Cartesian product. And since this gives us a Cartesian product, it doesn't really make sense to have, an on clause for cross join. Okay. And look at this. So far we have seen, writing query for joins. We have seen how to write inner join, left outer, right outer, full outer, and cross join. Now, depending on what we have done until now, it's pretty simple to develop a generic formula for joins. So what is that? Select what columns you want, or just say column list. Okay, select your column list. For example, I want name, gender, salary, department name, etc. Select column list from, maybe your left table, and then you specify the join type, inner join, cross join, whatever. And once you specify the join type, with which table you're joining, so right table, and on clause for specifying join condition. Okay, so if you compare this with what we have, okay, look at this. If it's an inner join, it would have been something like this. So inner join, and on we will have tbl department dot id is equal to tbl employee dot department id. So if you compare this generic formula with this inner join query, it exactly fits in. Select whatever columns we want from clause, the left table, and then the join type. Here it's an inner join, so we are specifying inner join. Otherwise, if it's a cross join, left join, we say left join, right join, etc. And then finally on clause and your join condition. So this is the generic formula, if you have a hard time, remembering the syntax for joins. Alright, so in summary, cross join returns the Cartesian products of the tables involved in the join, whereas inner join returns only the matching rows. Non-matching rows between the tables are eliminated. Look at these pictures, which will make the understanding of joins pretty much easy. Okay, so if you look at the inner join, only matching rows, left join, matching rows plus non-matching rows from the left table, and right join, matching rows plus non-matching rows from the right table. Whereas full join, matching rows between both the tables, non-matching from the left and non-matching from the right. Okay. On this slide you can find resources for ASP.NET and C# interview questions. That's it for today. Thank you for listening. Have a great day.